The work done is integral volume, the final.
The final one.
All right. The external pressure is greater than the internal pressure. What happens to work done? What takes place? Compression takes place.
While positive, sir.
When external pressure is greater than the internal.
Okay, sir.
And the so compression is going to take place. Meaning piston will go down.
Yes, sir.
On the other hand, if the internal pressure is lesser, so if external pressure is less than the internal pressure,
Expansion.
what will be your internal pressure?
Expansion, sir.
Expansion will be, absolutely. In which case, you can write it as external pressure can be the internal pressure plus some difference in pressure, or it can be even lesser. Be greater or it can be lesser. So can we write it as in plus or minus?
Yes, sir.
What will be work done in case of reversible process? In such a case, how can we write it? Club both of them. No change. It's all the same.
P external into del V, sir.
Yeah. If you express in terms of internal and dp,
Uh, P internal plus or minus dP into volume dV.
now when you look at, so you have dp, so p in, if you expand this, what is going to happen? Isn't it?
Yes, sir.
But this dpdv is going to be much dp into dv is going to be much smaller than your p in into dv. So what happens to your reversible curve? You can ignore that. In times But what is P is equal to from the ideal gas equation?
nRT by V.
Integral dV by V is going to be log V. So this is equal to minus nRT log V. V initial. This is integration formula, okay? Integral df
Formula, sir.
use then it will be what? 2.303 times the logarithm of x. That's the only change. Okay. Vf minus log Vi. Okay. But log A minus log B can be written as log
A by B, sir. Log A by B.
for bring the numerical value before. So it changes to what? Understood?
Yes, sir.
Next step. When is the work maximum?
When expanding, sir.
Very good. During expansion. During expansion. Wait. Expansion or compression?
Sorry, sir. Compression. Only compression will be there, no, sir.
So what happens for compression?
Internal pressure.
This can in compression. When expansion for compression, the external pressure has to be much greater than your internal pressure. In case of expansion, it will be the opposite. Okay, it's still possible.
Yes, sir.
When you go with compression, this the condition is this. During expansion, what happens? Your P external is less than your internal one. Here also, in both the cases, it is going to be max. Maximum work will be done either by the system or on the system. Is it?
Yes, sir.
Okay, so there is something called as free expansion. So what is called as free expansion? So free expansion is nothing but the gas expanding in vacuum with no external pressure on it. Okay, gaseous expansion in
Yes, sir.
and no external no.
Free expansion.
All right. Next, we'll see heat. What is this heat? Now, what is temperature? Before going to heat, let's try to understand what temperature. Temperature gives you an idea of something is with respect to something else, with respect to your surrounding, or coldness, right? How hot a place may measure that we call it as big temperature. So, and this temperature difference is going to be between the system and remember temperature is
System and surrounding.
as heat, and we will represent heat by okay. Now, and also remember it is a path function. Heat meaning it follows or depends on the path followed.
Work is also a path function, you say?
Depends on the if it depends on the path followed. It's called path functions such as heat and work. They're all path functions only. So
Yes.
when Q is positive, Q is what we said. Q is nothing but
Heat.
when Q is positive. What does that mean? Q Q is positive mean heat transfer